Welcome to Sri Vidya Academy for Special Education. Learning made easy. In this video, let us learn how to find the projection of a line on the plane. The given equation is x minus 1 by 2 equals y plus 1 by minus 1 equals z minus 3 by 4. This is the equation of the line, and the equation of the plane is x plus 2y plus z is equal to 6. Let us consider the given equation of the line and the plane. That is, we have x minus 1 by 2 is equal to y plus 1 by minus 1 equals z minus 3 by 4 is the given equation of the line. Let us call this as equation 1, and we will call this equation of the plane as equation 2, that is x plus 2y plus z is equal to 6. Now let me consider this diagram. Let this be the equation of the plane, that is x plus 2y plus z is equal to 6. We'll consider a line like this. Let A be the point of intersection of the given line and the plane. Let P be any point on the line. Let us draw a perpendicular from P to the plane. Let N be the foot of the perpendicular from any point P to the plane. Now we have to find the coordinates of A and N. Then we have to find the equation of AN, which is nothing but the equation of the projection of the given line. To find the coordinates of A, first I will consider a general point on the equation of the given line, that is equation 1. So we will take x minus 1 by 2 is equal to y plus 1 by minus 1 is equal to z minus 3 by 4 is equal to lambda. Let us take lambda as the parameter here. So therefore x is equal to 2 lambda plus 1, that is take x minus 1 by 2 equals lambda, we get x is equal to 2 lambda plus 1. Similarly, y is equal to minus lambda minus 1, and z is equal to 4 lambda plus 3. Now this point, that is x, y, z, satisfies the equation of the plane x plus 2y plus z is equal to 6, because this point lies on the plane. Therefore we will substitute these points x, y, z in the equation of the plane, that is equation 2. Therefore we get 2 lambda plus 1 plus 2 into minus lambda minus 1 plus 4 lambda plus 3 is equal to 6. We substituted the value of x, y and z in equation 2. Therefore lambda is equal to, that is 2 lambda minus 2 lambda cancels here, and we have 4 lambda, 1 minus 2 here, that is minus 1, 3 minus 1 is plus 2, so 6 minus 2 is 4. 4 lambda is equal to 4, which implies lambda is equal to 1. So we got the value of lambda now. Now when we substitute for lambda, we get the value of x, y and z, which is nothing but the general point, that is point A, which is the point of intersection of the line and the plane. Therefore A is nothing but 2 lambda plus 1, that is 2 into 1 plus 1, which is 3, minus 1 here, when you put lambda equals 1, y becomes minus 2, and z is nothing but 4 into 1 plus 3, which is 7. So we got a here. 3 minus 2, 7 is a. Now clearly this line passes through the point 1 minus 1, 3. Here equation 1 is the given equation of the line. Clearly this passes through the point 1 here, and here I have minus 1 and the point 3 here. So P1 minus 1, 3 be a point on the line. Let us take it as P, and let N be the foot of the perpendicular from P on the plane. Then direction ratios of Pn are proportional to 1, 2 and 1. That is, this is the normal, two equation of direction ratios of the normal to the plane. Pn is perpendicular to the plane. Therefore x plus 2y plus z, that is coefficient of x, coefficient of y and coefficient of z, are 1, 2, 1, which is proportional to direction ratios of Pn. Therefore equation of Pn is nothing but x minus 1 by 1 is equal to y plus 1 by 2 is equal to z minus 3 divided by 1. 1 minus 1, 3 are the points through which this line Pn is passing, and 1, 2, 1 are the direction ratios which are proportional. Now let us find the coordinates of n. To that end, let us take this as t. So we get x is equal to t plus 1, y is equal to 2t minus 1, and z is equal to t plus 3. Clearly n lies on the plane, that is t plus 1, 2t minus 1, t plus 3 satisfies the equation of the plane x plus 2y plus z is equal to 6. So let us substitute for x, y, z here. So we get this x plus 2y plus z is equal to 6 here. We substitute for x by z, that is t plus 1 plus 2 into 2t minus 1 plus t plus 3 is equal to 6. So upon simplification, I have 2 into 2t, 4t, 4t plus t is 5t plus t is 6t here, and 1 minus 2 is minus 1, 3 minus 1 is 2, and 6 minus 2 is equal to 4, which implies that t is equal to 4 by 6, which is nothing but 2 by 3. Now we can find the foot of the perpendicular by substituting for t equals 2 by 3 in x equals t plus 1, y equals 2t minus 1, and z is equal to t plus 3. Therefore n becomes 2 by 3 plus 1, 2 into 2 by 3 minus 1, and 2 by 3 plus 3. That is n is, I have 2 by 3 plus 1, 3 plus 2, 5 by 3 here. 2 2s are 4 by 3 minus 1, which is nothing but 1 by 3, and 2 by 3 plus 3. 3 3s are 9 plus 2, 11 by 3 here. So we got n as this point, and we have already found a, which is nothing but 3 minus 2 and 7, which are the coordinates of the intersection of the line and the plane. Actually, we are required to find the projection of the line on the plane like this. So we have a here and n here. Now we have to find the equation of an, which is the required equation. So if you take this a as x1, y1, z1, and n as x2, y2 and z2, we know that equation of the line when 2 points are given is given by x minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1 equals z minus z1 by z2 minus z1. So here x1 y1 z1 is 3 minus 2 7, and x2 y2 z2 is 5 by 3, 1 by 3 and 11 by 3. Therefore x minus 3 by x2 minus x1, that is 5 by 3 minus 3 is equal to y minus of minus 2. Y minus of minus 2 is y plus 2 by 1 by 3 plus 2, which is equal to z minus z1 is z minus 7, and z2 minus z1 is 11 by 3 minus 7. Therefore we get x minus 3 by x minus 3 by, so let us simplify the denominator. 5 minus 9 is minus 4 by 3, which is equal to y plus 2 by 3 2s are 6 plus 1, which is nothing but 7 by 3, which is equal to z minus 7 by 11 minus 21 by 3, that is minus 10 by 3. So that is nothing but x minus 3 by 4 is equal to y plus 2 by minus 7 is equal to z minus 7 by 10. So this is the required equation of the projection of the given line on the given plane. Thank you.